So when you want to do embedded programming, first step that you have to do is you have to identify your target and then have to study your data sheet of that particular target. This is the data sheet. Actually, this particular they used to release data sheet for combination of different groups of or family of controllers. Right. We are using 16F877A. Maybe there may be 8A, something like that, 5A, something like that. That's why they put X here. That means the X is you can replace that X with any number. Those were supported by microchip. Right. The controller that we use has 40 pins. Here, just they have given an overview 28, 40, 44 pin. But the controller that we have DIP version is having 40 pins. Right. So devices included in this datasheet. 16F877A, 4A, 6A, 7A. We are going to use this one. Right. Then high performance Risc CPU. What does mean by Risc CPU, Amir?
It is an architecture answer, Risc architecture.
That's what Risc means. What? Expansion of Risc.
Reduced instruction
Set. Yeah.
Yeah.
Right now. It is a reduced instruction set central processing unit. So it used to have very limited number of instructions. Right. There is another architecture. What is that one? Because like Risc, we have another one.
That is called as
complex instruction set CPU, like that. Right now. So only 35 single word instruction to learn. So the total instruction that you learn, instruction set are what you say, mnemonics. Mnemonics that you have to learn is only 35. As we have 35 keywords in C, this particular Risc instruction set is having 35 single word instructions. Right. Instruction means how it used to be move A comma B, move A comma B, and then B branch to particular, like that. There are some 35 keywords that we will see in this. This is part of this particular data sheet. Maybe somewhere it is mentioned in instruction set. We will see there right now, but total number is 35. So as we are going to do embedded C programming only, no, should we have to learn those 35 mnemonics? Practically, no. You no need to know about them. It's not important to you, because you are going to do what? Cross compilation. You are going to write program in embedded C, and then we will cross compile that to work for this particular microcontroller. So they will generate assembly instructions, everything. So I told one thing in the beginning when I was explaining about embedded C. Instruction set is also a zeros and ones. That is what I told, no? Do you remember that? The instruction given to, the command given to microcontroller also zeros and ones. So there will be some 35 different combinations of zeros and ones will be there. Right? It used to have some sort of I think 14-bit, I think so, if I'm not wrong. So if they will have some 35 into 14 bits set. Those were binary zeros and one combination. Right now, they were unique. Those are used as instruction. At the end of the day, when you compile your embedded C program, which is translated to initially assembly from their binary right now. So the binary zeros and one that we get at the end, the hex file that we get at the end will have instructions in zeros and ones. It won't have any mnemonic will be there or no C keywords will be available in that text file. That is clear now. That is what they are trying to say here. All single cycle instruction except for program batches, which are 2 cycles. That means all single cycle instructions except for program batches, which are 2 cycles. The program branching that we are doing now, from going from here to there, for that alone they consume 2 machine cycle. Other than that, rest of the instructions consume only 1 machine cycle. 1 machine cycle means your microcontroller operating frequency. 1 by microcontroller operating frequency is the time taken to execute one instruction. You got it now. To execute one instruction, that much time they will take. So it is very fast. Operating speed. So it is 20 megahertz clock input. So 200 nanosecond instruction cycle. That means 1 by 20 megahertz you will get this value right now. So that much fast you can operate this particular controller. So usually as we are operating microcontroller on 20 megahertz, it doesn't mean that we have to operate all peripherals that we have in that particular microcontroller in that speed. There are something called as prescaler. What is that? Prescalers within the microcontroller peripherals. So when they want to scale down this operating frequency to some extent, they can use those prescaler like clock frequency divided by 4, clock frequency divided by 8, clock frequency divided by 64, clock frequency divided by 128. Like that, they can scale down this master clock. So this is a maximum operating clock that they use for a microcontroller right now.
Sir, I want to sir. So in normal conditions, we are using this 20 megahertz clock input only, sir. And in which cases we will be reducing this use cases you will be reducing this clock input.
Okay, brilliant. You want to do process automation in some factory or something like that. There is processing instruction because the process will be happen in seconds, in the order of seconds. We no need to operate the controller. The system need not be fast enough. In those cases, we can reduce the operating clock. But from my view, in my experience, I had seen most of the microcontroller, they are operating at 20 megahertz only. Maximum frequency only they operate for, even for low speed operation or every operation they use a maximum speed. But we can reduce the speed. Depends on our process use case or process nature. We need to process some sort of microcontroller signals, the communication signal or something like that. In that time, operating at 4 megahertz is not sufficient right now. 4 megahertz or 8 megahertz is not sufficient. In those cases, we will increase the speed of the operating speed of the controller. What I am saying is, though you supplied your clock frequency as 20 megahertz for microcontroller, let's say I have an analog to digital converter which is inbuilt in this microcontroller. If I am operating microcontroller at 20 megahertz means it is not mean that I have to operate my ADC also 20 megahertz. It is not required. ADC will have something called a prescaler. Though the microcontroller is operating at 20 megahertz, ADC may operate at 4 megahertz, 8 megahertz, even 1 megahertz if they want to do. That depends on how frequently they receive the signal, how frequently the change happens in that signal. If there are a sluggish signal, which will happen every 5 seconds or 6 seconds only, there will be a change. Some cooling of a boiler or something like that. In those cases, operating ADC at 20 megahertz will give more sample to us that we don't require. See, if you are taking 10,000 sample in one time frame, your ADC is digitizing 10,000 sample, but all those 10,000 sample, nearly 9,500 samples are having same value because you are sampling the signal with high speed. So that much of sample you will get. Those were not needed. I am having my signal is going to change every 5 seconds only, which is very slow right now. Signal is going to change from one state to another state every 5 seconds. That is too slow in time. So for that particular physical signal, should I have to digitize that at 20 megahertz? Actually not required. If I do, I can do, but the sample that I get, no. In that 90% of sample will have same value. Agree or not? Because we are sampling, the change doesn't happen. Before, if your signal is changing at 5 second once, means you can even operate like your that's operating frequency can be less than 1K. Even in that, it will we can that operating frequency of ADC I'm talking about. Even in that, we will get more sample right now. So in that way, it depends on the nature of the signal that we digitize, and then process for which we use the microcontroller. Based on that, we will decide whether can we go for 20 mats for ADC. What can be the speed, operating speed? If we are using timer, do we have to pre-scale the timer to some extent, or we can use as such? So those decisions will be taken by embedded programmer. It depends on the project nature and project requirement. According to that, they will decide. Got it now?
So programmer has control to scaling down this.
Yeah, he has option to choose operating frequency of microcontroller, operation frequency of the peripherals within the microcontroller. He has a choice, right? He can choose. He will decide according to that. But you have to. There are certain requirements. You should not operate this microcontroller below this particular frequency. See, I want to operate the microcontroller itself at 1K. That is not advisable, because you will get lot of noise and other stuff. The reason why they go for high frequency to filter out the noise. Then you will get output, your processing will be faulty. So you can adjust your frequency of operating frequency of microcontroller to some certain level. It doesn't mean that you can reduce this microcontroller frequency. You can bring the microcontroller frequency even for 1K. You can bring it, but it doesn't make any sense. It won't produce any proper output. Does that make sense?
Yes, sir.
Yeah.